Hi and welcome to Foundations 20, Section 7.4, Example 1. This section here is on graphing quadratics using factored form. Okay, so this example says to sketch the graph of this function 2x squared plus 14x plus 12. Okay, so right off the bat here, we can tell from the fact that this is a positive 2, right, that it's going to open up. And this here, we should recall, is our y-intercept. Okay, so those are two handy things to recognize right off the start before we even get to factored form. Okay, so since we're using factored form, we want to factor this. So instead of writing it as f of x, I'm just going to switch that to y. Remember, when we're talking about things as a function of x, we're usually referring to that as our y coordinate. So we get y equals 2x squared plus 14x plus 12. And what we want to do is factor that. So to factor that, first thing we do is look for a GCF. In this case, there's a GCF of 2. So we factor that out of all the terms. Next step then is that 2 sticks around, and we have 3 terms, so we are looking at sum and product. So we're looking at two numbers that give us a sum of 7, so that's the middle one here, and that have a product of 6. So thinking about that for a moment, the numbers that do that are 6 and 1. So therefore our factored form is y equals 2 times by x plus 6, x plus 1. Again, it wouldn't matter if it was x plus 1, x plus 6. Okay, so now we have it in factored form. Recalling from what we explored in class, we found that these factors will give us what our x-intercepts are. So first thing we can do here is come up with our x-intercepts. So to get our x-intercepts, we could just look and go, okay, 6 and 1, and we have to change the signs. Or a better way to do that would be to take each of these factors and set them equal to 0. And then just solve the factors for x. This is x equals negative 6. This is x equals negative 1. Right, so those there are our x-intercepts. So right now we know it opens up. We've got a y-intercept. We've got 2 x-intercepts. Okay, the other thing we should find should be our vertex. So to find our vertex, we could first find our axis of symmetry. So to find our axis of symmetry, well, if we have 2 x-intercepts, so if we just kind of think of this, we've got here's an x-intercept, here's an x-intercept, right? Those are both on, right, the x-axis. Therefore, the axis of symmetry rate has to be halfway between them. So our axis of symmetry is going to be x equals, and we can go negative 6 plus negative 1 divided by 2. That gives us negative 7 over 2, or as a decimal, that would be negative 3.5. That might be easier for us to put on the graph. Okay, so we have our axis of symmetry is x equals negative 3.5. Therefore, we can find our vertex for that, right, because it's going to be at negative 3.5 and whatever the corresponding y value is. So our vertex, right, is negative 3.5, comma, and we have to figure out what that y value is. So to do that, right, we sub into our function. So we go y equals 2 bracket negative 3.5 plus 6, other bracket negative 3.5 plus 1. We simplify that out, okay, in a couple steps there, and we end up getting that that's equal to negative 12.5. So our vertex is negative 3.5, negative 12.5. Okay, so now we want to sketch the graph of this. So on our graph here, we're going to use all 4 quadrants by the looks of it. Looking at our numbers, we've got a vertex that's down at negative 12.5, so we need it to go down at least that far. It's opening up. Okay, so I'm going to draw it right, kind of like this. And also our intercepts are both negative x's, so I'm going to just skew this to the negative side a bit. Label these x, y, or x and f of x. So putting different points on here, I'll start with my vertex. So to do that, I'm just going to count these out. I'm going to go, I think I can fit these as ones, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, I can just fit them. So -2, -4, -6, -8, -10, -12. And then my x values, I should be able to do the same thing. Okay, so looking at this here, I have a vertex at the point -3.5, -12.5. So -3 is here, going down -3.5, -12.5. It is about there. So that there is my vertex. I'm just going to label that with a V, and -3.5, comma, -12.5. Next thing I'll put on there is my axis of symmetry. Right, so I'm going to put a dashed line through there, right, just indicating my axis of symmetry, and I'll label that as x equals -3.5. Okay, other things we have our x-intercepts of -1. Right, so that point there is -1, 0. Other x-intercept of -6. Right, so that point there is -6, 0. Okay, we can just double check. Are those 2 points the same distance away from the axis of symmetry? Yeah, they are. So we're good. Okay, other point we have, remember we also have that the y-intercept from up here, right, is +12. Okay, I'm not necessarily going to be able to fit that on my graph, but if I look at this here on my axes, I've got, so this here, 2, 4, 6. I can't necessarily fit that on there. It's going to be 8, 10, 12. It would be somewhere around up here, right? That which can also just kind of help us with the shape of this parabola. Okay, so then our last step here would just be to draw our parabola through these points. Remember, it has to be symmetrical. All right, so wish me luck. Okay, that's one side. Put arrows on it indicating that it continues like that. Other side. Okay, something like that. Okay, so we've got that. I'm just going to put my equation on there. So that was y equals 2x squared plus 14x plus 12. We should be labeling our equation onto our graph. Okay, and then the last part of this question we need to address is state the domain and range. Right, so what is the domain and range here? Well, the domain, again, it's x is an element of all real numbers. It extends both ways forever. The range, well, those are our y values. There are no y values below the parabola. Right, so the y values go up starting at -12.5, and they are real numbers. Okay, and that is that complete question. Again, there's our graph. We can see, looks very nice.